All right, so we're going to simplify variable expressions. We are going to use absolute value when appropriate. The absolute value rule says we need the absolute value when I have an even root of an even power and the answer ends up as an odd power. I need the absolute value because the even power is going to make it positive, so it will never actually come out negative. So we're going to simplify the fifth root of 4a to the 8th, b to the 14th, c to the 5th. When we did this last week, we just divided the exponent by the root, right? But it all came out nice and pretty for us last week. Now, not everything goes in evenly. So what do we do with the leftovers? And the answer is we leave them under the radical. Okay? So can I do the fifth root of 4? No. So I'm going to write my fifth root. And the 4 is going to stay underneath. And then we're going to divide our exponents. I can do the fifth root of a to the 8th, but it doesn't go in perfectly, right? 5 goes into 8 how many times? 1 with what left over? Remainder what? 3 remainder. So we get a to the first power left out front because it went in at least one time. I don't have to write the first power. And then we have to leave the other a cubed inside. Okay. So the 8 divided by 5 is 1, right? It goes in evenly one time with 3 left over. So the leftover a cubed stays under the radical.
What do you do with the other half?
Well, I'm not done yet. Like, I still got to do b and c, right? Right, so b goes in b to the 14th, so 14 divided by 5 is 2, so b squared. So 14 divided by 5 is 2, remainder 4, right? So then b to the 4th is left underneath the radical. And then I do c to the 5th. Fifth root of c to the 5th is just c.
Wait. So you're putting your remainder in the problem thingy.
Yes, in my radical, the remainder goes in the radical as the exponents, and however many times it goes in evenly goes outside the radical. 14 divided by 5 is 2, goes in 2, 10. 10 minus 14 is 4. Okay. Are we ready for number 2? The 2, yes, this is the second root, the square root. So there's a 2 there. So we're going to divide all the exponents by 2. But can I do the square root of 81? Yes, it's 9. So 9 is outside. And I'm going to do a to the 7th. What am I dividing by? 2. So 7 divided by 2. 3, remainder 1. So what goes outside? A cubed, because it went in 3 times. And what's left inside? A to the first power. For B,
It goes in evenly.
right?
By 6. So A6 goes on the outside?
B to the 6th.
By B6.
B to the 6 goes on the outside. There's no B's on the inside because it went in evenly.
And then
9 divided by 2 is 4, remainder 1. So c to the 4th, c. Now my radical looks a whole lot like 4th root there. Don't like that. Okay. Yeah.
So this doesn't break down anymore, it's still okay.
Yes. There's some left over under the radical. Just like when we're doing the square root of 45, right? 9 comes out because that's the 3, but the 5 has to stay under the radical. Okay. Now, let's look at number 3. Good news is I do not want you to even attempt multiplying x plus 7 to the 15th power. Okay? We're not doing that. If I can divide my exponents, this whole thing is in parentheses, right? So I can do 15 divided by 5 is what? 3. So that's x plus 7 to the 3rd power. And that's it. You don't have to multiply that out either. Please don't multiply that out. If it goes in evenly, the square root or the radical goes away completely. If it doesn't go in evenly, then you would leave a 1 inside. Or wait, say that again? I just did one. Right? This goes in evenly, so my radical goes away.
Oh, the okay. Yeah, that's what I was confused.
Yeah, so that went in evenly, so the radical went away. These did not, so there's still stuff under the radical. Okay. All right, now number 4. Now we're not allowed to have anything left over in the radical in a denominator. We're not allowed to have anything in the denominator that's inside a radical. So, is this going to go evenly end of the 7th? No. What would I need it to be to make it go evenly with the 5?
35.
Okay, yes, I could do 35, but let's go to the next smallest, 10, right? 10 is the next number greater than 7 that's divisible by 5. So how many more n's do I need? 3 more, right? So we're going to multiply by the 5th root of n cubed over n cubed. Right, because it makes 10. So I get the 5th root of 160 m to the 6th n cubed on the top, and the 5th root of n to the 10th on the bottom. Well, the 5th root of n to the 10th is just n squared, right?
Oh, whoa. I'm like away for 1 second. When do we get our test results back?
They're in the computer.
To see like which ones.
Oh, you can look at it after class if you'd like, but I won't be passing them back for a couple days. Okay. Not really.
I feel like she expected it.
Okay, so 160 is what? 16 times 10? And that is 8 times 2 and 2 times 5. And 8 is 2 times 2 times 2. So I have 5 2's, right? So it's 2 on the outside and a 5 on the inside. Right? 2, 5th root of 5. Well, this kind of is encroaching on it, so I'll move it over here. 2, 5th root of 5 is what the 5th root of 160 is. Because there's 5 2's, right? Under a 5th root, I'm looking for a group of 5 of the same number. So the 2 comes out and the 5 stays in. Yeah, it's 2 5th root of 5. Now, what about m to the 6th? What about that m to the 6th? 1 remainder 1. So I have m on the outside and m on the inside. Can I divide the 3 by the 5?
No.
No. So n cubed stays inside. So that's my final answer. Okay, and then the last thing, look at number 24 on your worksheet. I'm going to do this with you. Yeah.
Are we gonna have to do it on a separate piece of paper?
I don't think so. I think there should be plenty of space. Okay, so we already talked about, like on the quiz, there was a problem where you had like blank on the quiz. It was like 6 square root 10 minus 5 square root 10. And almost everybody got it right. 1 square root 10, right? Almost everybody. There was a few. There was a few that didn't get it. Okay, now, when we have these, and I don't have the same thing under the radical, right? What do I have to do? Simplify the radicals. So 20 is 4 times 5, and 4 is 2 times 2, right? So that's 2 square root 5 times the 6. So when there's a number in front, you multiply it by what comes out of the radical. So that becomes 12 square root 5. Plus the 8 square root 5, it already is simplified. And then 45 is 9 times 5, which is 3 times 3. So that's 5 times 3 square root 5 minus 15 square root 5, because that minus comes down. And now we're just doing 12 plus 8 minus 15. Twelve plus 8 is 20, minus 15 is 5. And what are they? We're adding up how many square root 5s there are, so 5 square root 5. That's my answer.